This is section 15.2. We're going to be talking about Euler paths and Euler circuits. An Euler path is a path that travels through every edge of a graph once and only once. Once and only once. Every edge of a graph. Remember the edges, those are the line segments, and the points are called vertices. Each edge must be traveled and no edge can be retraced. You can't leave any edges out, and you can't go over an edge twice or 3 times. An Euler circuit is a circuit that travels through every edge of a graph once and only once. Remember, since it's a circuit, it must begin and end at the same vertex. Assuming you have a connected graph, Euler's theorem, I know that looks like Euler, but that's not how it's pronounced. It's pronounced Euler. Euler's theorem says if a graph has exactly 2 odd vertices, then it has to have at least one Euler path, no Euler circuit. If a graph has no odd vertices, in other words, all the vertices are even, it has at least one Euler circuit. It could have more than one. And keep in mind that if it has an Euler circuit, it's also going to have an Euler path. So what this says is Euler circuit and Euler path. If it has more than 2 odd vertices, then it has no Euler path, no Euler circuit. This theorem is very important. This question shows up in your quizzes and on the test. Make sure that you know these 3 points and make sure you write them down. You will need these on quizzes. Using Euler's theorem, explain why the graph has at least one Euler path. Well, first thing you have to do is check to see whether the vertices are odd or even. And remember, odd or even depends on the degree. And the degree has to do with how many edges go into a point. So A has this edge and this edge going to that point or that vertex. So that's 2 edges going to vertex A. So 2 edges is an even number, so it's an even vertex. C has 1, 2, 3, 4 going into that vertex. So C is also an even vertex. As you can see, vertex E has 3 edges, so odd, D is odd, and B is going to be even. So explain why the graph has at least one Euler path. Well, to have an Euler path, you have to have exactly 2 odd vertices, which you have. D is odd and E is odd, so you have exactly 2 odd vertices. Use trial and error to find an Euler path. So let's start at vertex E, and I kind of randomly chose that vertex, although I'll tell you why I chose it in a minute. It wasn't really random. So then I'm going to go to vertex C. Let's go to A, to B. Let's go back over to C, down to D, over to E, back up to B, and then down to D. And I believe that gets every edge. So we went E to C to A to B, back to C, D, E, B, and D, I believe, was the path we used. Now, the reason why I chose to start at E is the one of the two odd vertices. If you're trying to find an Euler path, you have to start at one of the odd vertices. You're actually going to end up at the other odd vertex. E was odd and D was odd. So we started at one of the odd vertices. We ended up at the other. You must start at one of the odd vertices and at the other one. Using Euler's theorem to solve problems modeled with graphs. In the last section we talked about Königsberg. Well, the reason why this subject started being studied to begin with, a gentleman wrote his friend Euler and asked him to figure out a way to cross all of the bridges once and only once. So Euler came up with this new math called graph theory, and he decided that it was not possible to cross every bridge once and only once. The reason why, if you look at the vertices, which are the land masses, each of the vertices are odd. So the island A is an odd vertex. The right bank is an odd vertex. The island B is an odd vertex, and the left bank is also odd. Since there's three odd vertices, it is not possible to have an Euler path or a circuit. Fleury's algorithm to find possible Euler's paths or Euler's circuits. First thing you want to do, if a graph has exactly two odd vertices, choose one of them to start. If it has no odd vertices, choose any vertex to start. Number the edges as you trace through the graph according to the following rules. After you've traced over an edge, erase it and show the erased edge as a dashed line. If you have a choice between edges, first choose any edge that is not a bridge. Only go over a bridge as a last resort. Travel over a bridge only if there's no alternative. This figure has at least one Euler circuit. We can tell by looking at the vertices, and you're gonna see that they are all even. So we want to find at least one circuit using Fleury's algorithm. And like I said, you may come up with a different circuit than I do. I'm going to start at A. It doesn't really matter where I start since we don't have any odd vertices. And so if we start at A, we have to end back up at A. Let's randomly pick going to C. Now we have our choice. We can either go to E, F, or D. And since none of those are bridges, it doesn't matter. So let's go to E. Now I only have one choice, so I have to go to F. From here I have three different choices. I can either go to B, to D, or C. And none of these are bridges, so it doesn't matter where I go. So let's go back to C. I only have one choice for as long as I don't want to retrace an edge, so I have to go to D at this point. From here, I can either go to A, to B, or to F. I don't want to go to A because I want to end up at A. So I want to make that my last edge. So let's go, I don't know, let's go to F. I don't have any choices now for F, so let's go to B and to D and then to A. Euler circuit, you have to start and end at the same place. This is one example of an Euler circuit. They didn't do the same thing I did. It doesn't matter. As long as you start and end at the same place and you only go over each hedge once, you're fine. Your homework 2 through 38. I also want you to do 45, 46, and 52.